Every structure you see, from a simple house to the Burj Khalifa, depends on one thing: the materials chosen by the engineer. Welcome back to the Learning Studio. Today's episode in the Civil Engineering series explores the backbone of construction: engineering materials. Why materials matter. Most failures in construction don't happen because engineers miscalculate. They happen because someone picked the wrong material. Civil engineering begins with understanding what you're building with, not just how you're building it. 1. Cement, the glue of civilization. Cement is the powder that reacts with water to bind everything together. It forms the basis of mortar and concrete. Students must understand hydration, setting time, strength development, and the types: OPC, PPC, rapid hardening, low heat cement, because exams love these distinctions and real projects depend on them. 2. Concrete, the most used material on Earth after water. Concrete is cement plus sand, aggregates, water, but the behavior is far from simple. It's strong in compression, weak in tension, and endlessly customizable. From skyscrapers to dams, concrete is everywhere. We'll later explore grades, mix design, curing, workability, durability, and why modern infrastructure relies on reinforced and pre-stressed concrete. 3. Aggregates, the skeleton of concrete. Fine and coarse aggregates make up nearly 70 to 80% of concrete by volume. Their shape, size, texture, and moisture content can make or break a project. Good aggregates equals strong structures. Bad aggregates, cracks, failures, disasters. 4. Steel, the muscle of modern structures. If concrete is the body, steel is the muscle. Steel handles tension, bending, shear, forces that concrete alone cannot resist. Reinforced concrete works because steel and concrete expand at nearly the same rate. We'll cover rebar types, grades like Fe415, Fe500, Fe600, welding, corrosion protection, and why steel is critical for bridges, towers, and high-rise frames. 5. Modern composites, the future of construction. The future of materials is shifting fast. Engineers are moving toward FRP, fiber-reinforced polymer, GFRP and CFRP reinforcements, geopolymer concrete, self-healing concrete, ultra-high-performance concrete, UHPC, smart materials with embedded sensors. These materials are lighter, stronger, more durable, and more sustainable. AI and ML now help predict material behavior, optimize mix designs, and reduce waste by simulating thousands of combinations impossible to test manually. These were the essentials of engineering materials, the foundation of every civil project. Explore the full civil engineering playlist through the link in the description and share the series to support the global education movement. See you in the next lecture.